So we had really just left one thing on the table here, which is to compute the reflection off of this combination of units. And I thought that we should do this before we proceed on to some of these more complicated ideas. Now, if I want to calculate all the possible ways I can get a reflection, you can see the first contribution is just where I come along and have just reflected off of my initial barrier. So I can denote that again using my little notation. These are the two key scattering locations, and I could just have a reflection off of that first up step, and that then gives me an R plus. So that term would be pretty simple, just that R plus. I could just immediately reflect off. The next term is going to be a bit more complicated. It will look something like this. That is where, if we want to look up at it over here, I come across, I transmit into the interior region, I hit this back wall, partly I transmit of course, but then we're talking about the part that then reflects and then finally transmits out to give this second reflection contribution, like so. So, for that, drawing it a little more neatly, it would look something like this. And we can now compute each of the different contributions along the way. I'm transmitting across this first up step. I'm propagating across. I then have a reflection off the far step, which is a downward step. So that will be an R minus, just like in my ricochet factors. I would then have a P. And now notice I'm transmitting out on this side, and as I transmit out that side, I'm transmitting out a case where the potential is dropping down, so that will be a final T minus. So let's write in that term. So it's a T plus P R minus P, and then a final T minus. Okay, I think we're ready for the next term then. So you can see, although there's a lot to track, it's all fairly intuitive. That's the beauty of this Feynman approach. It's all fairly intuitive, and it's certainly a lot more fun than just solving boundary conditions. So let's look at the next event. The next event would have to involve an extra ricochet in here. So I'm going to bounce back and forth an additional time then before I'm finally transmitted outward. And we can see then that we will have our T plus, our P, and now we're going to begin one of these ricochets, right? We're going to have an R minus, a P. This is again an R minus. Whenever I hit this potential coming from this side, it looks like a step down. That will be P. Another R minus, just like we had before then, a P and a T minus. So at this point, I think we can start to see the structure then of these subsequent terms. And so I think we're about ready to do the final summation. The next term here is going to have yet another ricochet involved, like so. And it's going to continue in that type of a fashion. So, just as we had done before, what we would like to do is identify the common terms in these different sequences of events. And you'll notice that all of them begin with a TP, right? They all begin with a TP, right? And there's also a TP here. We can just see it. I'm not going to label it. And they all end then with this final reflection and transmission outward. So there's always this final set of factors, which I will circle like so, and they look like thus, right? So using the same strategy we had before, I will separate these out with dots. So this term has a TP, a dot, and then the final three stages are PT minus. Now this one begins with a TP. There are some terms in between that we will look at, but then again I end on the R minus PT minus. And what happens in between should look pretty familiar to us. This looks like our standard ricochet. After this TP, there was an R minus P, R minus P, R minus P, R minus P. It's exactly the same ricochet event that we had studied in the series for the transmission. In this next term, you can see I've got the reflection, propagate, reflection, propagate. That's one ricochet factor. Then again, a reflect, propagate That's just 2 reflection factors. So you can see, or ricochet factors we're calling them, it's going to be this structure, T plus P times R minus P to the nth power, the final R minus P T minus. So then, we can now sum this series. The one tricky thing to notice, though, is that it isn't a perfect geometric series. This first term looks different from the others. Right? It's a special type of term. It's just a special case where just reflecting off the first boundary all by itself just fits into a different sequence than the others. The others all have a common structure. This one structure is quite different. So there's always just this R plus out in front. Then what I have is from here on, I either have the same term with no ricochets, with 1 ricochet, with 2 ricochets. This is now, the rest of this is a geometric series. And again, that we know how to sum. It's always the first term, which is transmit first across, then propagate across. Then on the end, we always have to reflect off the back end and propagate and then transmit through the first end. And then that's divided by 1 minus the geometric factor, which is, again, this ricochet factor, R minus P, R minus P. And that then is the reflection coefficient. And again, the beauty of these two things is that if you take these and then you simply insert the precise definitions that we get from solving the simple single step scattering problem, you will get exactly what we would have gotten if we had actually solved the more complicated wave boundary value problem, which isn't nearly as much fun as summing up over all of these histories.